On a hot day, 8,000 years ago, a traveler journeyed through the desert with some milk in a pouch. The pouch was likely the leak-proof stomach of a sheep or goat. However, when the traveler went to take a sip of the milk, they only found a soft, white jelly inside. The solidified milk turned out to be the first version of one of the most beloved foods worldwide, cheese. But how did the cheese become solid in the first place? Well, we have biochemistry to thank. Cheese begins with milk, which is packed full of nutrients and vitamins. The most important biological molecule in cheesemaking is a protein called casein. Casein proteins join together to create spherical aggregates, known as micelles, which float around suspended in the milk. Casein exists in 4 forms in milk, all with slightly different amino acid chains. Amino acids are the building blocks of proteins, and each amino acid interacts differently with others. Therefore, different sequences lead to different 3D structures of the protein, which is responsible for the 4 versions of casein. Kappa casein is the only form that is hydrophilic, or water-loving, meaning they are polar molecules with a positively and negatively charged side. They are attracted to the polar water molecules outside, so they exist on the surface of the micelle. Kappa casein is what prevents the micelles from clumping together, keeping the milk liquid. To make cheese, you really only need 4 things: milk, starter culture, rennet, and salt. Starter culture consists of lactic acid bacteria, such as Lactococcus lactis, which change the lactose sugar into lactic acid to make the milk more acidic. The new environment kills unwanted bacteria and contributes to later flavor and texture development. Next, rennet is added, which is a collection of enzymes that speed up chemical reactions. These enzymes work better in the more acidic environment, as rennet was originally discovered in the acidic stomach linings of animals. The most significant enzyme in rennet is chymosin, a protease. Protease enzymes break down proteins, and chymosin specifically snaps the kappa casein in 2, destabilizing the micelle and allowing many to join together to form coagulums, in this case, solids called curds. Now that the curds are formed, cheesemakers focus on removing the remaining liquid, called whey. Whey, comprised mostly of water, attracts other polar molecules like lactose and protein as it is removed, leaving only the non-polar micelles without the kappa casein protrusions. The casein physically traps other solid molecules like a net, including the fat, vitamins, and remaining lactose molecules that add to the nutritious and flavorful compounds within cheese. Salt can also be added to further remove whey through osmosis and to prevent unknown bacteria from growing. Cheesemakers then heat and combine the remaining curds before letting them harden into cheese. Thanks to bacteria and casein proteins, the science behind cheese is mozzarella incredible and brie-licious.